Well, we started in 1982, really, after I'd finished with another company that looked as though they were going, unfortunately, to go bust. So I commenced the company with one other director and 2 or 3 other employees. And we built it up over a period of time, moving from a company in Kiln Farm over to this property that we took over in 1990, and have expanded this gradually over the years until today.
Okay, and how many employees do you have?
We have 14 employees.
Can you explain the differences between EDM and ECM, please?
Yes, EDM stands for electric discharge machining, originally called spark erosion. And basically, it's a method of removing material by a series of discrete sparks that's caused on a DC circuit by the spark having a certain amount of heat taking material from the component and gradually eroding the material away until you get the reverse shape of the electrode. On electrochemical machining, or ECM, what it does is uses a positive component and a negative electrode. The two are brought close together and driven into the workpiece with a saltwater solution between the two, and the material is removed by electrolysis. So it's a continuous operation, and the continuous operation produces a very good surface finish, and again the reverse image of the electrode that's used, or the tool. So the two are different in the fact that although they both use an electrical method of removing material, one gives you almost an orange peel effect finish, which is EDM, and the other gives a very smooth finish. And the reason why you'd use one more than the other is EDM is very easy to tool up, where electrochemical machining needs a specific fixture.
Okay. Obviously the team at MTD are helping develop EDM and DCM sales within the UK. Is this a growing market for you?
Oh yes, it is, particularly the EDM side and the version of electrochemical machining called electrochemical deburring. This is used on a fairly simple machine where we don't have a moving quill, but it removes burrs from the component, particularly on difficult areas that's internal. This component is an aluminium part which has been milled and left quite bad burrs, particularly on the upstands that you can see on the component. This had to be deburred quickly because there's a very large component. We use a version of electrochemical machining called electrochemical deburring, and this is a static electrode put very close to the burrs itself. We turn the power on and it removes the burrs and leaves a very smooth and radiused finish. This is an example of wire erosion, or wire EDM, and this displays the ability of the process to produce a different shape at the top of the component and the bottom of the component. On this you see that this is a spade on one side and a club on the other, and this displays the piece of material that this has come from. So again, you've got a spade on one side and a club on the other. And if I put the two together, you will see that the gap between them is very small between the two, and this shows how precisely parts can be made. This is a component that is produced by EDM using a 4th axis on the machine, which allows the component to be indexed from one position to the next. So on one operation it produces the aerofoil shape that you see in the component just through the skin, and then indexed to the next position to create the next part. In this way it gradually moves around until all the slots are produced in the component. It's part of a turbine, and this is the blade that fits into it, which goes through this slot, and then on the outer of this you have another casing which goes round, and this has got rectangular holes to accept this component inside it. The flow of gas comes between the cone and the outer casing across these blades to create a flow for the turbine that's behind it. This is a racing conrod made out of titanium, and the requirement was to put a hole between the small end and the large end for oil purposes. This is produced by using EDM drilling, which uses a hollow brass electrode which is rotated with fluid between it, which creates the hole between the two to a very precise size. This could not be done by any other method because of the depth to diameter ratio of the hole. This is a turbine disc that's created by first of all turning and then by electrochemical machining, which produces this blade profile by using a hollow electrode, creating that one particular blade in one in one operation, and then indexes to the next position and creates the next blade, and so on until all the blades are completed on the profiles. Each one of these only takes about 4 minutes to machine, and is a very fast process with no electrode wear and a very good surface finish, so it's used quite extensively in the aerospace industry. This component is made out of S80 stainless steel and is part of an air motor where two of these components lock at 90 degrees to each other and are rotated by compressed air from the engine of the aircraft, which rotates the component and drives via the square in the end to the flaps of the aircraft. This is used on the multi-role combat aircraft and operates the flaps. The difficulty on this was to remove the material from these two shapes that you see here, which makes it very much lighter, and we tried it by 3 different methods. The first method was to mill it, and because of the small radii, this took about 4 hours to machine. We then used EDM, and this brought the time down to just over 2 hours. And finally, we used electrochemical machining, ECM, which brought the time down to 55 minutes. So these two pockets themselves are produced in 55 minutes, both at the same time, and create a component which is very much in balance.
And here at Anotronic, you actually are subcontractor for these services, but you also offer the machine as well. I presume you're fairly unique in that aspect.
I think we are, yes, because not only do we do the normal 5-axis and other machining, we offer electrochemical machining, electrochemical deburring and EDM, and this I think has helped us to get complete part manufacture from many suppliers.
Okay, have you got any investment plans in the near future?
Oh yes, we will be buying more. I mean, we've recently purchased other machines on the 5-axis machining side, but we are looking to produce produce more machines for electrochemical machining. We've got one in manufacture at the moment for deburring, a 1000 amp machine that we'll be using ourselves. And also on the EDM side, we'll be bringing in our SKM machines from Taiwan and be using more of those ourselves as well.
Okay, Norman, so what's the future for Anotronic EDM, DCM?
Well, to continue to grow and to sell more machines. When people don't want subcontract, we'll supply machines, and vice versa. So the whole idea of it is that we both make and sell machines and use subcontracts, because when times are hard, people tend to use subcontract, and when they've got plenty of money, they buy the machines. So we use both.